All right, Algebra 2 trig students. Today our goal is, upon completion of this lesson, students should be able to solve quadratics with or without imaginary numbers. Solve the quadratic equations using radicals, exact answers. Now this means no decimals. All right, let's get started right away. Here, equation A, x squared minus 289 equals 0. I want to get x squared by itself so I can solve for x. So add 289 to both sides. And when I do that, I will have x squared equals 289. Now, to get rid of the x squared, what I'm going to do is square root both sides. So if I square root this side, I have to square root this side. Now, we always have to remember, if I'm going to square root to solve, I have to put a little plus or minus there. It's a little hard to see, but there's a plus or minus in front of there. All right, now, whenever I take the square root of x squared, I also get x. And the reason why that is as you've learned before, when you're taking square roots, you're looking for pairs of things, and before you learned it with numbers. But here we can do it with variables too. If I take x squared and break it down, I can break it down into x times x. And if I circle up here, the x comes out and I've solved for it. And so that's why taking the square root of x squared is x. Now, you can go ahead and use your calculator. All right, now, take the square root of 289 and you get the whole number 17. But remember, right here is a plus or minus. So there are two answers to this, plus or minus 17. Now, if we were to get a decimal in our calculator, that means we would have to break this number down and simplify it. And that's what this means with exact answers. All right, now why two answers? Well, because we all know if we square a positive 17, all right, we'll get 289. You can check that in our calculator. That's just the square root backwards. 289 minus 289 is 0, so that one checks out. Well, what happens if we square a negative 17? Since a negative times a negative is a positive, that's also 289. So we get two answers for these square root problems. All right. Now, we'll move over to this next problem, problem B. All right. I need to get x squared by itself. I'll actually circle this. It's always best if we circle our answers because we're going to have a lot of work for these problems. So, okay, back to B. I'm going to add 10 to both sides. All right, when I do that, I will have 2x squared equal 10. Divide both sides by 2. So this is just a little more work than the last one. Then I'll be down to x squared equals 5. Now, 5 is a pretty small number. It's actually prime, which means I'm not going to be able to break it down. We'll go ahead and take the square root of both sides. And again, plus or minus square root. All right, don't ever forget that. It's easy to lose a lot of points on a quiz or a test if you always forget your plus or minus. Now, like I said a second ago, 5 is a prime number. I can't break it down any further, so this answer looks like this. All right? So sometimes you have just a number, and sometimes you have a radical in your answer. All right? A variety of things can happen. All right. Now, so far, we really have had just what we call real answers. We haven't had any imaginaries yet. All right, let's look at C. I'm going to subtract 25 on both sides. Now, don't worry that this is a y squared. We can deal with it just the same as that. So, y squared. So we'll solve for y. It's going to equal negative 25. All right. Now we see the negative in there. When I take the square root of y squared, well, we're okay with that. Don't forget the plus or minus square root of negative 25. Now, I'm going to remind you that the square root of negative 1 is equal to I. We just defined that as the imaginary unit number I. All right. Now, so what that means is the square root of y squared is y. And the way I like to deal with this, and you can go ahead and really rewrite this if you want to, but you've dealt with these, this will be the second day you've dealt with the imaginary part. You just didn't solve equations with them. If you take the square root of a negative, you're going to get an I that comes out of here. And so if I just think of this as the square root of 25, the answer would be, oh, I almost forgot my plus or minus. All right, right away, I caught myself. We'll put the plus or minus there. The square root of 25 is just 5. That's a perfect square. If you don't know that one, you can either break it down real quick. I could break it down over here. It breaks down into 5 times 5, and you get a pair of 5s. So the 5 comes out, nothing stays in. But the other thing that is actually still inside there, if I just look at this as positive 25, is the square root of negative 1. And we all know that we can bring that out as just an I. All right? And so this answer is plus or minus 5i. There's a minus right there. I almost covered up. So y equals plus or minus 5i. All right? Now, this problem here, D, we will subtract 1 from both sides. 3x squared equals negative 36. Divide by 3. And so x squared equals negative. Actually, I need a little more room for that. Sorry about that. Let me give myself a little space. Negative 12. Now, I'm going to square root both sides. Again, I want to make sure I have room for my plus or minus in there. I don't want to try to squeeze it in so you can't see it. All right, now we have plus or minus. Now I know when I'm done with this problem I have an I with it because it's taking the square root of a negative. So the other thing I need to do, and I'll just use this space right here, is break down the 12. So 12 is not a perfect square. If you took the square root of 12 in your calculator, you would get a decimal, which means you know we have to break it down. So we're going to break this down. Let's try 4 times 3 and 2 times 2. All right, which means I know that 12 is the same as 2 times 2 times 3. So if I circle a pair of 2's, I know a 2 comes out of this root, but a 3 has to stay in. But the other thing that comes out because of this negative is an I. And so x equals. All right, now we're going to write this in a certain order. This 2 comes out. And then the negative, the square root of that negative, like we said out here, is an I. And then it's the square root of what stays in? The 3. So now we can kind of see with all these problems here, and let me circle this. Oh, what did I forget? Hold on. I wrote the plus or minus here, but in my final answer, let me give myself a little more room. It's real easy to forget. You should always check. In my final answer, I got a plus or minus. So I moved my equal sign over just a little bit. So notice, all 4 of these answers have plus or minus in them. The top 2, we took the square roots of positives, so we didn't have I in the answer. The bottom 2, C and D, we had the square root of some negative number, so the answer had an I in it. Now the I always comes out of the square root. Some students accidentally leave the I in the square root. All right? So don't always think you always have an I in a problem, or you never do, or so just make sure you don't overgeneralize when you're doing these problems. All right, let's continue on. So I will subtract 4. Whoops. So I'll subtract 4 from this. So 1/3 x squared will equal 8 minus 4 is 4. And now, whenever I want to get rid of a 1/3, I can multiply both sides by the reciprocal. So I'm going to multiply times 3 over 1. And so this will become x squared equals 12. And this becomes very similar to the last problem, except for notice, it's positive 12, not negative 12. And so I'm going to square root both sides, make sure I plus or minus. And I'm not going to break this problem down because we just did it. The 12 will break down into this answer will be very similar. It's going to be 2 root 3. The only difference is I don't have an I. So the square root of 12 is not the same as the square root of negative 12. It's very close. I get plus or minus 2 root 3 instead of plus or minus 2i root 3. All right, problem F. Now this does look a little different. Now at first you might think, oh, I have to FOIL this and then multiply by 3 and that would be a ton of work. But actually it's a lot shorter than that. So because this is one big product here, I can go ahead and divide both sides by 3. And so I have now x plus 4 squared equals 9. And now this also looks a little strange, but because this whole thing is squared, I don't have to, again, FOIL this out, move everything to one side and get just an x squared by itself. I can square root this whole thing right now. And so I'll square root this side, and then I'll plus or minus square root the 9, which gives me an x plus 4 equals, now 9 is a perfect square, plus or minus 3. Again, if you're having a hard time and you don't know that 9 is a perfect square, just break it down. And these won't break down any further. So 3, you get to circle a pair of 3 because it's the square root, so a 3 comes out. There's no square root left, or you could have used your calculator to see that you do not get a decimal. All right. So now here's an interesting dilemma. I've got 2 answers here, and it's a little more tricky than it might look. I'm going to subtract 4 from both sides, but when I do that, I'm going to put the 4 that I subtract right here. And notice there's no I in this problem because I took the square root of a positive. Now, I really have 2 things going on here. I want to know what happens with x when I take negative 4 and add to 3, and then when I take negative 4 and subtract 3. So negative 4 plus 3 is negative 1, and negative 4 minus 3 is negative 7. And we'll circle those. Now, those are 2 different answers. Now, in a lot of problems we've done so far, we got plus or minus some number. And in this one, we got 2 different numbers, and both were negative. All right? So both can be negative. Both could actually be positive. All right? So let's do this next one. G. I'm going to divide both sides by 2. Very similar to the last problem. I'm going to have x squared plus 4 equals 5. Now the difference here is I have the squared on the x. Here on the last problem, it was outside the parentheses. So now I can't square root both sides right now. I need to subtract a 4 from both sides. So it was very similar in that I divided by 2 first instead of distributing, which made it easier. But then I go ahead and weight the square root because my squared is inside the parentheses. So x squared equals 1. And when I take the square root of both sides, now 1's a perfect square. That's kind of a nice one. So I'm going to end up with x equals plus or minus 1. All right. I think we have time. Actually, I'm going to stop there. I have a few here that I want you to try. I think we've done enough of these. So I want you to finish H, and as you'll see below, there are also 3 more that I'd like you to try for in class. And I will give you a hint on this one. It's very similar to when I had 1/3 and I multiplied by 3. But eventually here I will first add the 3 and then have to multiply by negative 5/2, the reciprocal. So I'm going to go ahead and let you finish H and then also I, J, and K, and we'll check those in class. All right. See you in class.